Hello everyone, this is Mr. Jackson, and today we are going to be going into Unit 2, Lesson 2, Part 1, where we're going to be discussing the properties of water and why those are so important. So this is a water molecule. You've probably heard us refer to the water molecule before as H2O, referring to the fact that there are two hydrogen atoms bonded with one oxygen atom here in the center. Now, all of the special properties that water has going for it that make it so important and critical for life on Earth to exist, this is mostly because the water molecule itself is considered to be polar. This means that the charges will be unevenly distributed, so there will be a partial positive side and a partial negative side within the same molecule. And so if I click my screen here, you can kind of see what that internal structure of the molecule looks like whenever we consider the electrons that these molecules have. So let's start with oxygen. Again, oxygen is atomic number 8. So that means not only are there 8 protons here in the nucleus, but there are also going to be 8 electrons surrounding the nucleus. So in that first shell, we can expect to find 2. We've got those here. And then in the second shell, specific to the oxygen, I could expect to find the other 6. So that's 1, 2, 3, and then 4, 5, and 6. Now, in the first layer, I can hold 2. In the second layer, I can hold up to 8. And atoms really like to be stable, and we achieve stability by having full outer shells of electrons. Right now I've only got 6 out of 8. And so I can technically occupy 2 of those blank spaces if I have atoms surrounding me that enable me to do so. And it just so happens that with our hydrogen happens to be atomic number 1, meaning that there's 1 proton in the nucleus and 1 electron that surrounds that nucleus. In that first shell for hydrogen, in order to have a full outer shell, that only shell it has, I would need 2. So I've currently got 1 out of 2 for each of my hydrogens. And so if I were to bond, to share a covalent bond between hydrogen and oxygen, if I were to share one of my valence electrons between the two, what I can actually do is I can fill simultaneously the valence shell of hydrogen, both of my hydrogens, and because I've now brought in those missing 2 electrons, 1 from each hydrogen for my oxygen, I now have a full valence shell here. And so that would create my 8 out of 8. And so we've achieved high stability. And if, once we've achieved that, what's going to happen is that we're going to see a partial positive and a partial negative. Here's why. Whenever I bring in those new electrons for my oxygen, remember, oxygen has 8 protons. That's a lot more positively charged than the 1 proton that my hydrogens have. And so since positives attract negatives, my electrons are now going to really stay closer to that high pulling 8 proton nucleus of my oxygen, right? So they're going to gravitate here. And so that's where you see this this partial negative charge on your oxygen, and that's going to leave a partial positive charge for each of my hydrogens because most of the electrons have gone towards the oxygen nucleus. And so then we also talked, so that's within the water molecule itself. We also have how these water molecules can actually come together with each other. So this attraction between a hydrogen atom with a partially positive charge and any other atom, especially another water molecule like an oxygen from another water molecule with a partial negative charge, anytime we have that attraction, we call that a hydrogen bond, right? Because it's that partial positive of the hydrogen that brings in a partial negative to bond. And because this attraction between molecules or between atoms is only partially charged, these bonds are relatively weak compared to your ionics or covalents. And so now I want to get into a few of the unique properties of water. And each of these we're going to play with in class with a few activities so we can actually see how these work. And we're going to discuss a little bit about their importance right now. The first unique property of water is referred to as cohesion. Cohesion is that attraction between molecules of the same substance. So in this case, the example would be water sticking to water, right? It's the way that water molecules attract and hold together with each other. This is the tendency of molecules basically of the same kind to stay together. And what this actually will do is cause really high surface tension of water. So this is just a measure of how difficult would it be to stretch or break the surface of a liquid. So water is going to have really, really high surface tension because of how cohesive those molecules are to each other. Cohesion also happens to be why water will form beads on smooth surfaces. And so a couple of examples to your right of cohesion would be like the surface tension of water allows really light objects or organisms like this bug to actually float on or walk on the surface of water because it doesn't have enough mass to break the surface tension of water. And then you can also see cohesion whenever you think about these little beads here on this spider web, how those beads are that water cohesively sticking together and holding itself to other water molecules. The next property that we could look at has a very similar name, but it is different. We have adhesion, so not cohesion, but adhesion. Adhesion is whenever we're going to basically add a different substance in. This is the attraction between molecules of different substances, which actually will form stronger bonds than cohesion. So some examples of this would be maybe the meniscus that you see, sort of that little crater-like top whenever you fill, let's say, like a graduated cylinder with water. You see it kind of dips or craters, and the reason that is because the attraction that water has to something like glass is actually greater and will remain sort of more tightly elevated than the dip in the center where it's exclusively just those hydrogen bonds with water molecules. So that's a meniscus. That's one way it works. Another way is through what we call capillary action. You can see that down here in bottom left, where if I were to stick a tissue into the water in one glass, capillary action would be basically how we draw water up and out and into another cup, right? It happens a lot with plants where we draw water up and out of the roots of a plant up into the stems and leaves so that water and nutrients can get to all parts of let's say a tree or something like that. So that's adhesion, different substances. Water also happens to have really high heat capacity. That's referring to the amount of energy that we need to raise a substance's temperature by making its molecules move faster. Water is going to resist changes and fluctuations in temperature. It doesn't change very easily. This will allow bodies of water like oceans and lakes to actually absorb really large amounts of heat with only small changes in temperature. And it also works the other way, where if you see down here, the only reason why these fish are able to live during really, really cold seasons and where there's might be like ice forming on the surface is because even though it gets really, really cold outside, the entire body of water isn't going to be nearly as affected as maybe just the surface, and especially not as much as the air, the temperature of the air above. And so this is actually what allows life to live in water, and it helps keep our climate moderate, right? No large fluctuations in that. And then finally, we're going to wrap up with water as a universal solvent, okay? And in order to know what that means, this is going to require a couple of key terms. So first key term would be that of a solution. When I refer to a solution, this is going to be a uniform mixture of two or more substances. A good example would be lemonade. Within lemonade, you'll have both a solute, that's what gets dissolved, that's like your lemonade powder, and a solvent, which is what actually does the dissolving, and that's our water, right? So water is a very, very good solvent because it helps dissolve otherwise solid substances like lemonade powder to where it uniformly will mix within the solution. So water's polarity is actually going to give it the ability to dissolve ionic compounds, other polar molecules, more so than any other liquid, right? So salts and sugars dissolve easily in water, and that's really good because it helps us break down bigger macromolecules and bigger molecules so that we can use their smaller component parts. And so that is going to wrap up our initial discussion of water and its unique properties, and I hope this was helpful.